In today's video, I'll be solving 25 Jamb calculation questions, and that will be covering topics like electrochemistry, solubilities, stoichiometry, gas laws, and thermochemistry. All right, if you have not subscribed to this channel, please, I want to plead with you to please support this channel by subscribing. God bless you as you subscribe now. Please subscribe. We have a lot to offer you on this channel. I upload videos on organic chemistry, on inorganic chemistry, on physical chemistry, on spectroscopy, for undergraduate chemistry and pharmacy. I want you to please hit the subscription button now. God bless you. All right, let's look at the first question. The question says that what quantity of current is required to deposit 2.4 grams of copper in a period of 750 seconds during an electrolytic deposition. Okay, so now I would like to use simple formulas for you in electrolysis. Okay, so look at this formula. Have you seen this formula before? M equals to MIT over EF. Now this M is the mass deposited. This capital letter M is the atomic mass of the element deposited. I is current, T is time in seconds, E is the electron pass. You know, when you are talking about copper, we have copper 2 plus. Copper will exist in this form of ion as copper 2 plus. So plus 2 electrons giving us copper. So this electron is 2. So F is 96,500 coulombs. All right. So let's put in everything and make I the subject. So we have 2.4 equals to 64 times I, which is what we're looking for, times time. Time must be in seconds. So 750 seconds. Time must be in seconds. So you have to convert to seconds. It's not present in seconds, or if not given in seconds. So E now is the coefficient of the electron, which is 2. And F is 96,500. So if you make I the subject, we are going to be having 2.4 multiplied by 2 multiplied by 96,500 divided by 64 times 750. And that's going to give us 9.6 amperes. So therefore, option A is the correct answer. Now, question number 2 says that calculate the volume of chlorine in centimeter cube given up during electrolysis or electrolysis if this amount of amperes is passed through concentrated sodium chloride for 193 seconds. All right, now I don't know if you have seen this formula before. This could be your first time of seeing it, so it makes life very easy. The volume given up is VIT over EF. Can you see? It's just like this. So this capital letter V is volume at STP, whereas this small letter V is volume given off. All right, now this is the question. This VIT is a constant. It's volume at STP, which is 22.4 dm cube, which is 2,400 cm cube. I is current, so we put everything there. We're going to be having, okay, so capital letter V is 2,400 cm cube, and I is 10 amperes, and T is time in seconds, which is 193 seconds, and E is 2. Now, for gases, E is 2 for gases. but it's going to be 4 for oxygen. For all gases, E will be 2, but for oxygen, it's going to be 4. So E is going to be 2. Now, because you're talking about chlorine, that's from Cl minus to give you Cl2 plus 2 electrons. And that's what happens for most gases except oxygen. So F is 96,500. So you put in everything there now, you're going to find out that V equals to 2,400 times 10 times 193 seconds divided by E, which is 2, 96,500 coulombs. So we're going to find out that the volume involved is 224 cm cubed. That's very simple, right? So look at question number 3. It says that what volume of oxygen is given off? So we use the same formula. That's VIT over EF. So this is the volume at STP, which is 2,400 cm cubed. I is what? Current, which is 0.75 amperes. Time is what? 20 minutes. That is 20 times 60, all divided by. So this 20 minutes to be converted to seconds will be 20 times 60. So divided by E. I said earlier that E for oxygen is usually 4. So that's 10 times 96,500 coulombs. So you press your calculator. So you press the calculator, you are going to get 52.2 cm cubed. So the reaction for oxygen, how oxygen is produced is, oxygen is produced from OH. So you're going to get 4 OH minus. So it's going to be giving you 2 moles of water plus 1 mole of oxygen plus 4 mole of electron. So electron will be 4 in the case of oxygen. I believe that's very simple to understand. So we go to question number 4 now. Question number 4, how long would it take to deposit 0.08 gram of zinc from zinc chloride by passing a current of 0.5 amperes? Now, you can record with the formula I used earlier that M equals to MIT over EF, for zinc 2 plus, we take 2 electrons to give zinc solid. Okay, so E here is going to be 2, F is 96,500 coulomb, T is the question, I is 0.5 amperes. This capital letter M, remember I said is the atomic mass of the element. So M is the mass deposited. So we have 0.08 equals to M as 65 times I, which is 0.5, times T, which is the question, divided by E, which is 2, times 96,500 coulombs. So you're going to have T to be 0.08 times 2 times 96,500 coulombs divided by 65 times 0.5. And that's going to give you approximately 8 minutes. The answer you get will be in seconds, then you convert it to minutes by dividing with 60. So question number 5. Calculate the quantity of electricity required to deposit 28.64 gram copper from its source. Okay, so question number 5, that M equals to MIT over EF. Now you will need to know that this IT is the quantity of electricity. So I can write this formula. I can write it as M equals to MQ over EF. So this M is 28.64 equals to this one I told you is the atomic mass of the element, which is 64. So times Q divided by So for copper, we saw it earlier that copper is copper 2 plus, so it will take 2 electrons. So therefore, E is going to be 2 times 96,500 coulombs. So that Q is going to be 28.64 times 2 times 96,500 coulombs divided by 64. And when you press your calculator, so you find out that's going to be 86367.5 coulombs of electricity. So that's going to be option D. Question number 6 says that an element J of relative atomic mass was deposited by electrolysis. So if 1.99 gram of element was deposited on the cathode when 1.9 amperes of current flows for 90 minutes, what is the charge on the element? So you know that J, so we have J, we don't know the charge on J, so plus n number of electrons will give us J solid. This J aqueous. So therefore, this E is the unknown. So the E is the unknown, right? So we have mass to be equals to MIT over EF, right? So you're going to be making E the subject. So I can rewrite the formula as E equals to what? So we're going to have, so E is going to be MIT over EF. So you are having this M is the atomic mass of the element, which is 56, and I is the current, T is the time, which is 90 minutes. 90 is converted to seconds by multiplying it with 60 divided by what? Oh, sorry, this one is M. So this M, so let me make it neater so that you won't be confused. So we have, so this one is going to be MF. So you press the calculator now. So that's going to be 3. So the answer is going to be 3. Now, is it going to be plus 3 or minus 3? Now, since they said it was deposited on the cathode, and you know that cations migrate to cathode, it then means that the J, the element J or the ion J must be a cation. So since it's deposited on the cathode, I believe that is very simple enough. So we go to question number 7 now. Question number 7. Calculate the mass of magnesium that will be deposited by 8 Faradays of electricity. Okay, so now we can record that M equals to MIT over EF. Okay, so the M is the question. Now, capital letter M is the atomic mass of magnesium, which is 24. IT is this quantity of electricity, 8 Faradays. 8 Faradays, you can record that 1 Faraday is 96,500 coulombs. Quantity of electricity, IT, so this IT is coulombs and it is 8 Faradays, okay? So this one is 8 Faradays. So that's the quantity of electricity. So the E for magnesium, you can recall that we have magnesium 2 plus 2 electrons is going to give us magnesium. So therefore, we have M to be equals to what? So that is what? 2 times, 24. Atomic mass of magnesium is 24. So this IT is the quantity of electricity, which is 8 farad. Then E, which is 2, because you have 2 electrons. So here, then times 96,500 coulombs, or times 1 Faraday. So that is Faraday, cancel out this Faraday, and then 2 goes here, that is 4. And so when you press your calculator, you will have 96 grams. So that's why option A will be the correct answer. Question number 8. So what mole of copper 2 plus will be deposited by 360 coulombs of electricity? Now we can recall that M equals to MIT over EF, right? So if you make, you divide both sides by M, we have capital eta M, we have this one equals to IT over EF. So you know that mass over molar mass is what? Is mole. So that's why we say mole under Faraday is equals to IT is Q over, so that's mole in electrolysis. When you are asked to calculate the moles in electrolysis, you just remember this formula immediately. So therefore, N equals to what? Q, which is the quantity of electricity, so which is 360 coulombs of electricity. So divided by what? For copper, we know it's going to be copper 2 plus, so it's going to require 2 electrons. That's 2, then 96,500 coulombs. So if you press the calculator now, what is that going to give you? That's going to be 0.00187, which is 1.87 times 10 raised to the power minus 3 moles. I believe that is very, very simple. Question number 9 says that the concentration of a solution obtained by dissolving 0.53 grams of pure anhydrous sodium carbonate in water to make 250 cm cube of solution is what? Now you know that to calculate concentration is what? Mole, concentration in mole per dm cube, concentration in mole per dm cube is actually mole over, that is mole over volume in dm cube. You can remember that mole is equals to mass divided by molar mass. And volume in dm cube is volume in cm cube divided by 1000. So therefore, mass, what's the mass of the salt? It is 0.53, right? So divided by, what is the molar mass of sodium carbonate? At least as a regular science student that will be solving this, you know that sodium carbonate will be 106. Let's do that. Sodium is 24. 24 times 2 plus 12 plus 3 times 16. See, oxygen is 16. By the time you press your calculator, everything will give you 106 grams per mole. So we put it there, 106 grams per mole. So you divide it by volume in cm cube is what? 250. So you divide 250 by 1000. So you press your calculator, that's going to give you 0.02. So that's going to be 2.0 times 10 raised to the power minus 2 mole per dm cube. I believe that is very simple. So that is concentration in mole per dm cube. Now let's go to question number 10. Question number 10. Says that 3.06 gram of a sample of potassium triazochlorate 5 was required to make a saturated solution with 10 cm cube of water at, sorry, this is 25 degrees C, not 250 C. So that's 25 degrees C. Say that the solubility of the salt at this temperature is what? Now, when you want to calculate solubility, solubility in mole per dm cube has the same formula as concentration, which is equals to mole over volume in dm cube. Okay, now, so therefore, so now we're going to be having what is the mass of, the mole, which is mass over molar mass divided by volume in cm cube divided by 1000. So so we have this mass. What's the mass of the salt? That's 306 gram. What's the molar mass of potassium chlorate 5? So you do that, you see that's going to give you 125 gram per mole. Okay. Now, so the volume in cm cube is 10. So let's put everything in there. So we have 3.06 gram divided by 122.5 gram per mole divided by 10 all over 1000. So you can press everything into the calculator, and that's going to give you 2.50 mole per dm cube. See how simple it is now. Question number 12. So we are still using the same formula. Solubility in mole per dm cube is mass over molar mass divided by volume in cm cube volume in cm cube divided by 1000. Now, what is volume in cm? What is the mass of the salt? The mass of this salt is what? Is 20 gram. Now, what is the molar mass of copper sulfate? The molar mass of copper sulfate, if it is given to you at 63.5, then the molar mass of, when you press everything together, that's 63.5 plus 32 plus 16 times 4, that's going to give you 159.5. So divided by one, what's the volume in cm cube? Now, they said 100 gram of water. 100 gram of water. When you hear 100 gram of water, it means 100 cm cube of water. The reason is because 1 gram of water is 1 cm cube of water, because the density of water is 1 gram per cm cube. So 1 gram of water means 1 cm cube of water. So this 100 gram of water means what? 100 cm cube of water. Yeah. So now, so the volume in cm cube now is 100 cm cube. So divided by 1000. So by the time you press your calculator, you're going to get, that should be 1.25 mole per dm cube. So if it were solubility in gram per dm cube, you will not divide it by the molar mass. Solubility in gram per dm cube is mass in gram. That was the mass given. Then over volume is cm cube divided by 1000. So, but for our question, it is in mole per dm cube. Now, question number 12 says that the solubility of a salt of molar mass 100 gram per mole at 20 degrees C is 0.34 mole per dm cube. If 3.4 gram of the salt is dissolved completely in 250 cm cube of water in beaker. The resulting solution is A saturated, B unsaturated, C supersaturated, D a suspension. Now, when you look at this question, you will ask yourself, if 3.4 gram of the salt is dissolved completely in 250 cm cube of water in beaker. Now look at this. So you will first need to ask yourself, if this amount of the salt is dissolved in this amount of water, what is the solubility? So that if I compare it with this one, is it above this one? Is it equals to this one? Is it less than this one? All right. Now, so that's what you do. So you calculate the solubility of the salt. Solubility in mole per dm cube. So which is equals to mass over molar mass divided by volume in cm cube over 1000. Now, what is the mass of the salt? So the mass dissolved is 3.4. And what is the molar mass of the salt is 101 gram per dm cube. Volume in cm cube is what? 250 over 1000. So by the time you press your calculator, that's going to be 0.135 mole per dm cube. Now you can see that this one is less than the actual amount that should be dissolved. So therefore, it means that the solution is unsaturated. If it is actually equals to it, then you say it is saturated. If it is above it, then you will have said it is supersaturated. All right. So therefore, the solution, the correct answer is going to be option B. I think that is very simple enough. So if you have any question, you can just put it in the comment section down below. Question number 13. Question number 13 says that what volume of 0.5 molar H2SO4 will exactly neutralize 20 cm cube of 0.1 molar sodium hydroxide? Now you see that this is a neutralization reaction between an acid and a base. So life is very easy with this. What you just need to do is first write the balanced equation between sodium hydroxide and H2SO4. And you know that this is going to give you sodium sulfate plus H2O. So you balance the equation. So here is having sodium. So you're going to put 2 here, and then it means that there's going to be 2 here. So it means that the ratio of base to acid is 2 to 1. Or the ratio of acid to base is 1 to 2. Now you can remember that CA VA over CB VB equals to NA over NB. Now, what is CA? The coefficient of H2SO4 is 0.5 times VA, which is the unknown, because the question says that what volume of H2SO4? So volume of H2SO4, which is VA, is the unknown. So then CB is what? 0.1. And the VB is 20. Na, so what's the mole of the acid? That's 1. And the mole of the base is 2. So therefore, so VA now is going to be, when you press your calculator, you make VA the subject, which is going to be 2. It's going to be 2.0 cm cube. So it's just as simple as that. Question number 14. Says that what volume of 0.75 mole per dm cube sodium solution could be diluted. Now, this is a dilution question. This is going to be talking about dilution formula. So, you know, dilution formula is C1 V1 equals to C2 V2. So they say what volume of 0.75 mole per dm cube sodium carbonate solution will be diluted to 250. This will reduce the concentration. So this is this V2, this is the C2. So we are looking for V1 and C1 is 0.75. So we have 0.75 multiplied by V1 to be equal to C2, which is 0.025 times V2, which is 250. So therefore, so we have V1 to be 0.025 times 250, so divided by 0.75. And if you press your calculator, you find out that the correct answer is 8.3 centimeter cube. All right. Now, question number 15 says that calculate the molecular mass formula of a compound with a empirical formula C2O and vapor density 60. Now, you can remember that empirical formula, let me use empirical, that's empirical formula multiplied by N is equals to molecular mass. Now, the molecular mass is related to vapor density by what? Know that if it is the vapor density that's given to you, molecular mass is equal to 2 times the vapor density. So therefore, we have C2O into N equals to what? 2 times 60. And so we have this one is 12 plus 2 plus this one. That's going to be 30. N equals to 120. And so we have N to be equals to 4. You put everything back into it. We have C2O4 to be what? C4H8O4. And that's why option B would be the correct answer. I think that's very simple enough. Question number 16. What is the percentage of sulfur in sulfur 4 oxide? Now, this is a very simple question, but very common question. The percentage of an element in a compound. So the percentage of sulfur is going to be mass of sulfur in sulfur 4 oxide divided by the mass of sulfur 4 oxide times 100 times 100. Okay, so that's what happens. Now, in this place, we have in sulfur 4 oxide, we have just one sulfur, and so that's going to be 32. The molar mass of sulfur 4 oxide is 64. So, you know, sulfur 4 oxide. So sulfur, just one sulfur there is going to be 32. Then the whole of everything is 32 plus 16 times 2, which is 64. So times 100. And that's going to give you 50%. So that's option D. Question number 17. 24 gram of magnesium react with diluted hydrochloric acid. Calculate the volume of hydrogen gas given off. You know that if hydrochloric acid reacts with magnesium, it's going to give you magnesium chloride plus hydrogen. So it means that you balance this one with 2. So now, what is you will have to calculate the mole of magnesium so that you can use it to calculate the mole of the hydrogen. So the mole of magnesium is mass over molar mass, which is the mass given is 24. The molar mass of magnesium is 24 gram per mole. That's going to give you 1 mole. Now from balanced equation, you can see that there is 1 mole of magnesium, 1 mole of hydrogen. So if 1 mole of magnesium produce 1 mole of magnesium, then this 1 mole will also be 1. So the mole of hydrogen is the same thing as the mole of magnesium. So therefore, the mole of hydrogen is going to be 1 mole also. You can recall that volume is equal to mole times 22.4. So that's going to be 1 mole times 22.4, and that's going to be 22.4 dm cubed. So question number 18. So the correct answer to number 17 now is option A. Let me get more space. Boron has 2 isotopes. If the isotope of this one has this abundance, determine the atomic weight of boron, given that the other 2 isotopes has a mass of this. Now, the relative atomic mass, when you are asked to calculate determine the atomic weight, which is the same thing as relative atomic mass. So atomic weight is the abundance of the first isotope multiplied by its mass plus the abundance of the second isotope multiplied by its mass. So that's how you solve for isotopy. Is very straightforward. Now, the first one, which is 19.78%, and the mass of that one is 10.013. So plus, what's the abundance of the second one, the second isotope? So they didn't give us in the question. It means that you are going to subtract this from 100. So the abundance of the second one is going to be 100 minus this. Okay. And if you do that one, it's going to be 80.22 as over 100, because it's in percentage multiplied by the second, the mass of the second isotope. And when you press your calculator, it's going to give you 10.81 atomic mass units. It's just as simple as that. And that's why option A is going to be the correct answer. Before I solve the very few questions that remain, I would like to share with you from the book of Genesis, chapter 8, verse 22 says that while the heart remaineth, seed time and harvest, and cold and heat, and summer and winter, and day and night shall not cease. Inasmuch the earth remains, seed time and harvest time shall not cease. Now, what am I trying to say in essence is this: whatever you do, you are sowing a seed. If you are reading very hard, you are working very hard, you are sowing a seed. While if you are not sleeping, if you are not reading, if you are not working hard, you are also sowing the seed of laziness. And when you sow the seed of laziness, you will definitely reap nothing. You will definitely reap poverty, but you will not be poor in Jesus' name. If you are sowing hard work, you are going to reap success. So I want you to understand that when you are sowing, it's not always easy to sow, to go and work and to put things in the soil so that it will germinate and it will give abundance or harvest for you. It's not always very easy. So what I'm trying to say in this is that God has done it. God has structured it like that, that in as much the heart remaineth, seed time and harvest time shall not cease. So this time that you are preparing for your UTME is a time that you are sowing. You are sowing. So I want you to sow with wisdom. Get past questions, use our videos, meet your colleagues, anything that you don't understand, make sure you get it by force. Make sure you understand the concept and pass your exam. You know, they that sow in tears, the book of Psalm 126, verse 5, they that sow in tears shall reap in joy. If you can sow in tears, the true pains, through the rigors, just give your best to it. Don't consider the pains that you are putting in to prepare for this exam. If you sow in tears, you will reap in joy. I pray that you will get success in this UTME this year. I pray that this year UTME will be the last UTME you will write in Jesus' name. In the book of Psalm 32, verse 8, it says, I will instruct thee and teach thee in the way which thou shalt go. I will guide thee with my eyes. If you give your life to God, He will instruct you, He will teach you in the way you should go. He will lay some questions, some areas of chemistry, of biology, of mathematics, or any topic you are doing. He will lay them in your heart. God says He will guide you, He will instruct you and teach you in the way you should go, and He will guide you with your own with His eyes. Have you given your life to Christ? Have you given your life to God? Jesus is the way, the only way, the truth, and the life. No man comes to the Father but by Him. He's the way. He died on the cross. He gave Himself. You know, some people came back after 500 years, after 600 years, after 1,000 years that He has died. They said that Jesus Christ did not go to the cross. Whereas the eyes witness, those people that saw it themselves, they, they gave the testimony that they saw Him, they took Him out of them, and they went to crucify Him, and He rose up from the dead. They went to His grave. The grave was no longer there. The clothes has been wrapped well, and He showed up Himself to them that He has risen up. Jesus. And then in their very eyes, He ascended to heaven, and they gave this record. Please accept Jesus, and He's going to help you. He's going to bless you. He's going to make a way for you. In Jesus' name, please don't let go of God's hand. Stick to God. Call upon God to help you as you are reading, as you are preparing. Always be asking God, God, give me success. God, give me success. And I pray that this exam, God will give you success in Jesus' name. Give your best. It's not very easy, but give your best. The sleepless nights, the night candle, please burn it and pray and be a friend of Jesus. It shall be well with you in Jesus' name. Amen. Now I go on to solving the questions. Question number 19. A given volume of methane diffuses in 20 seconds. How long will it take the same volume of sulfur oxide to diffuse under the same condition? Now, when you look at this question, you see that this is a question under Graham's law. And so we have time of methane. I told you, if you have listened, if you have watched my video on Graham's law, the secret behind Graham's law, you are going to understand that it's only in the case of time, whereby if we have time of SO2 here, then we have the molar mass of CH4 here, and we have the molar mass of SO2 here. So methane here, if it is time. So, but for other parameters like rate, like distance, volume, it's not like that. It's only in the case of time. So that when you have time of CH4 here, you have molar mass of CH4 here. Okay, so the time of CH4 is 20 seconds. And the time for SO4 is what we want to find now. The molar mass of CH4 is going to be 16. And the molar mass of SO2 is 64. So that we have 20 over X to be equals to, that's 4 over 8. And so if you press your calculator, you find out that X is going to be 40 seconds. Question number 20 now. The relative rate of diffusion of a gas. So let's the gas be equals to X. So gas X. So as compared with sulfur oxide is this. So the rate of X over the of sulfur 6 oxide is, of course, now this rate, because this is rate, not time. So it is not molar mass of X that will be here. It is molar mass of SO2. They are inverse. And then this one, the molar mass of X. Okay, so that's for that. That's how it is. Only in the case of time that is the same. But for rate, they are not the same. All right. Now, the ratio of the rate of diffusion of the gas X to this one is 5. So the rate of gas X is root 5. So we got that come first. Then the rate of SO2 is 2. Then the molar mass of SO3, it is sulfur 6 oxide. It's sulfur 6 oxide. So that's going to be root 80. The molar mass of sulfur 6 oxide is 80. So the molar mass of X. So what do? You square both sides. So if you square both sides, you're going to have 5 over square of this one. This one is going to be 80 over m of X. So if you press the calculator and you make mx the subject, so we have mx to be equals to 2 squared times 80 divided by 5. And that's going to be 64 grams per mole. All right, question number 21 says that the pressure exerted by a sample of a gas confined in 5.86 dm cube container at 20 degrees C is 4.1 atm. What is the numbers of moles of the gas in this sample? Now, when you have to calculate the numbers of mole of gas, when you are given volume, temperature, pressure, and the gas constant, then you know that N equals to PV over RT. That is from PV equals to nRT. That's from ideal gas equation. So therefore, so we have P, that is 4.1 atm, and the volume is 5.86 dm cube. R is 0.082, and the temperature is 20 degrees C. So you convert it to Kelvin, that's 293 Kelvin. And so if you press your calculator, that's going to give you 1.0 mole. 1.0 mole. So that's why option A will be the correct answer. Here is option C. D. Here is option C. So that is very simple, very simple. Question number 22 says that 70 cm cube of hydrogen has powered with 25 cm cube of oxygen at STP. So the total residual gas is what? Now, you write the first, that's the question on Gay-Lussac law. And the first thing, if you have watched my video on the tricks to solving Gay-Lussac law, you are going to understand the simple steps to solving questions on the Gay-Lussac law. You can't watch that video and miss any question on Gay-Lussac law. I can show you of that. So you should check it, check this channel and you get it. Okay. Now, what you first do is to write the balanced equation of reaction. So the first thing you are going to write is the initial volume. So the initial volume, you are given 70 cm cube of hydrogen, you were given 25 cm cube of hydrogen. Here you are not given any volume. Now you write your the mole ratio, the mole ratio. The mole of this one is 2, the mole of this one is 1, the mole of this one is 2. Then you identify the limiting reagent. How do you identify the limiting reagent? You said 70 divided by 2 is 35, 25 divided by 1 is 25. So that is limiting value. Me dividing the initial volume by the mole ratio is what we call limiting value. And the one that is lower, the one that has a lower limiting value is the limiting reagent. So this one divided by this one is 35, this one divided by this one is 25. So 25 is less than 35. So it means that oxygen is the limiting reagent. And all the 25 cm cube of oxygen that reacted will react. The initial volume of the limiting reagent must react. And the amount of this one that reacted, you don't know. The amount of this one produced, you don't know. So you say reacting or produce volume. So reacting or produce volume. So therefore, it says 2 equals to 1, S is equal to 25, you cross multiply. So which means that if 25 of oxygen reacted, 50 cm cube of hydrogen must react. So, and the same thing applies to water because 2 is 2. So if 50 of this one is reacted, then 50 cm cube of this one will be produced. All right, so it's just as simple as that. So what we have here is this one, 50 cm cube of this one will react, 50 cm cube of this one will be produced. So this one, you subtract it, it's going to be 20 cm cube. All of this one has reacted. This one is 50. But mind you, the final condition of measurement is at STP. At STP, water will not be a gas. It will turn to liquid. So this is the only the gas that is remaining. So that's the residual gas. So the answer is going to be 20. It's 20 cm cube. Now, question number 23. Question number 23. So, now the enthalpy of reaction is enthalpy of formation of products minus enthalpy of formation of reactants. Now the product is this one. So it's going to be 2 times the enthalpy of formation of SO2 minus enthalpy of formation of SO2. So multiply by 2 because that's a mole of 2 plus the enthalpy of formation of oxygen because oxygen and O2 SO2 are the reactants. So therefore, so we're going to have that's 2 into minus 396 minus 2 into this one, which is minus 297. Now, the enthalpy of oxygen, because oxygen is an element, is in its all combined state, is in its pure state. An element in its pure state, we have enthalpy of formation to be equal to 0. So we have this on 0 now. So now the final answer when you press your calculator is minus 198 kilojoule. So that is just that. It's just as simple as that. So that's why option B will be the correct answer. So use this diagram to answer question 24 and 25. The activation energy of the uncatalyzed reaction is what? Now, this is the uncatalyzed reaction. If we want to calculate the activation energy is the difference between the energy of the activated complex and the energy of the reactants. The energy of the activated complex and the energy of the reactant. When you look at the energy of the reactant, this is reactant, this is product in energy diagram of reactions. So when you look at the energy of the reactant, it is 200 kilojoule per mole. So the energy of the activated complex is 400 kilojoule per mole. So you're going to find the difference between them. So that's 400 minus 200. That's how to calculate activation energy. So the energy of the activated complex minus the energy of the reactant. And when you do that, that's going to give you 200 for the catalyzed reaction. For the uncatalyzed reaction, for the catalyzed reaction, uncatalyzed reaction usually have a higher energy, activation energy. Okay. Now, when you look at the catalyzed reaction, the energy of the activated complex is 300. So 300 minus 200 will be 100. So that is the activation energy for the catalyzed reaction, this one. So, but the uncatalyzed is this. So that's option B will be the correct answer. Question number 25. The enthalpy change for the reaction is what? Now, enthalpy is what? The enthalpy of the product minus the enthalpy of the reactant. So the product is having energy of what? 100. So that's going to be 100 minus, and the reactant is having 200. So that's why it'll be minus 100. So that is an exothermic reaction. And that's why the coordinate looks like this. So that's why option B will be the correct answer. I believe you have gained maximally in this video. Please, if you have not subscribed to this video, kindly hit the subscription button. Please support this channel by subscribing. God bless you. I am indeed very grateful. Thank you for staying to the end of this video. God bless you. I wish you abundant success in this UTME. I wish you the very best.